This is a piece of footage by the National Aeronautics and Space Administration from Langley on the Little Joe boosters. Now, the Little Joes were developed, there were solid-fueled rockets that were developed because as boosters were being secured for the Mercury program, it became apparent that the boosters that would be used, the Redstone for suborbital flights and the Atlas for orbital flights, would be quite expensive. In fact, at the time, while in the world of rocketry this doesn't sound like much today, the Atlas was going to be $2.5 million each, and the Redstone was projected to be $1 million each. And they needed something a little cheaper in order to test some of the especially the escape rocket, the launch escape system, the tractor rocket on the Red Tower and the top of the Mercury spacecraft. They needed to test this, obviously, before putting a man aboard, and they didn't want to use an Atlas or Redstone rockets to do it. So actually as early as January of '58, considerable work had been done on developing clustering 4 solid-fuel Sargent rockets, which were in standard use at Wallops Island to boost a manned nose cone above the atmosphere. This was later developed further into the Little Joe rockets. And the way that the Little Joe got its name was as it was being developed, it became apparent that the cross-section drawings showed 4 holes up. And so they called it Little Joe from the crap game throw of double deuce on the dice, which was called a Little Joe. And this name later stuck, and actually the Little Joe 2, which was a similar solid-fueled launch vehicle that was used at Apollo in testing the Apollo launch escape system, became the Little Joe 2, so the Little Joe name stuck. Now what you're seeing here is the construction of one of the boiler plates that was used on some of the early Little Joe flights. And that kind of fiberglass container was where the onboard recording devices would be. It was something of the cabin in this particular spacecraft, and then the boiler plate was built up from it. This would actually be considered a Type D spacecraft, although a boilerplate of what was a Type D spacecraft. Some other places on this disk set you'll see a Type C spacecraft, which had a much steeper angle and a longer nose, but was seen to be relatively unstable compared to the Class D, or the Type D design that was later used in the production Mercury spacecraft. Here the antenna canister, the drogue compartment. But getting back to the development of the Little Joe, North American Aviation built the Little Joe. The contract was awarded on December the 29th, 1958, and work began immediately. And the Little Joe was designed so that here you're seeing some weight and balance, was designed to reproduce the flight regimes that the Mercury capsule would experience when boosted by either a Redstone or an Atlas. And with the boost of the solid fuel rockets, it was able to do that. This was done because they wanted to test the capsule escape system at maximum dynamics pressure. They also wanted to qualify the parachute system and also work on their search and retrieval methods for recovery. There were a lot of elements of the end of the Mercury missions and also the launch escape system that were really worked out by the usage of the Little Joe. The Little Joe came out to cost about 1/5 the cost of a Redstone. And North American, when they won the contract, the order was for 7 booster airframes and 1 mobile launcher. Here you see that compartment. Now, all of the Little Joe spacecraft were designed to be recovered. Therefore, most of the data that they were hoping to grab on each one of these missions could be recorded internally, since it was meant to be recorded. Since each of them was recovered. Now, there were some other aims of Little Joe that could be that could be derived from some of the Little Joe missions. Those of pressure loads, noise levels, some work on some of the separation techniques that were used later. And even though it was the only booster system that was designed specifically in total for manned capsule qualifications, it was also one of the pioneering launch vehicles using the cluster concept. It had 4 modified Surgeons, which were called either Castor or Pollux rockets, depending upon how they were modified, and 4 supplemental recruit rockets. And these were arranged to fire in various sequences, so the takeoff thrust varied greatly from mission to mission, but maximum design thrust was almost 230,000 pounds. Now, this was enough to lift a spacecraft of about 4,000 pounds on a ballistic path over 100 miles high. Now, the push of these main engines could simulate the takeoff profile that the manned Atlas would experience. And also the explosive pull of the tractor rocket escape system could be demonstrated on the most severe of the abort profiles that they needed to look at. Now, even though the Little Joe could simulate a number of the flight regimes of the Redstone and of the Atlas, it was not powerful enough to put it in to situations to test some of the other spacecraft development issues, such as re-entry heating. And for that purpose, an actual Atlas was used. And that Atlas, the first use of it to really study what would happen to the spacecraft as it went the speeds it was developed to go to, would end up being called Big Joe. And that first Big Joe, here you're seeing the firing of some sort of pyrotechnic initiators. That first Big Joe would be on an Atlas, and it was designed to test out heat shield and some other structural and dynamic issues on the Mercury spacecraft using an actual Atlas. It was originally planned that the Big Joe was going to use an Atlas C, but as it turned out, it did use an Atlas D and was a success. Here, the packing of the parachutes, an antenna canister being loaded, looks like with a drogue, perhaps. It's a drogue canister. Looks like this is the loading of the drogue. There was some qualification problems with there's the drogue parachute, with the drogue, and it was considered being deleted at one point, but there wasn't a viable alternative. They did use a destabilizing flap at the top of the Mercury spacecraft, which were deployed in orbit. And this was designed that if there was no way to control the spacecraft, it would flip the spacecraft around so that its aft heat shield was pointing in the direct, was pointing its blunt into re-entry, so that if there was no control ability on the spacecraft, it would re-enter the atmosphere in the proper orientation. Here again we see preparation of the antenna canister portion of a boilerplate used in the Little Joe launches. I do not have a direct idea on which Little Joe mission this is preparation for. And this would have been footage at Langley or Wallops Island. Here we see the escape tower. One of the things that I find fascinating about some of the Mercury material is just how hands-on this was. Here we see the clamp, quite possibly the famous Marmon clamp. And a fairing. Now we're getting to an actual Little Joe airframe. As you can see here with some of the fens. There's your Little Joe. There's a Little Joe airframe, at least the top section. And here we have one of the solid rockets. A jet thrust unit, Class A explosive. Now sometimes when looking at the Little Joe, one forgets that you're still dealing with quite a powerful launch vehicle here of considerable size. Anything that's capable of hurling a 4,000-pound payload 100 miles. Here we see out on the launcher the thrust units being put together. This would have been at Wallops Island. Again, there was not specific documentation on what flight preparation this was for. However, hard hats were required in this area. There's the escape tower, the boilerplate spacecraft, and now we see the airframe has now been connected to the top part of the Little Joe. We've got capsule being hoisted to the top of the Little Joe. At one point for some of these tests, the Jupiter and the Thor rockets were also considered, but this turned out to be the most economical and most reliable choice on these tests, in that the Jupiter and the Thor, while it would have given them a few more options in terms of the regimes in which they could test the spacecraft, it was considerably more expensive and more complex than this. So we see a fully ready Little Joe.